Chris showed this slide as well at his opening. We view actually automotive as a bit of an interplay between not only autonomy, which you heard about from Chris, and safety, but also with infotainment and electrification. And actually we see that infotainment, which is really more about interaction between the passengers or the driver and the car, actually driving autonomy, if you will. So there's an interplay back and forth. And as far as electrification goes, we actually see that as a platform onto which autonomous vehicles are created. So let's first go into electrification. So electrification, actually we see the industry changing from kilometers per liter, or as we say in the US, miles per gallon, over to kilometers per millivolt. And it's a bit of a change, not only in the buzzwords, but also in the way, obviously, that the cars themselves are manufactured and the way that they perform. So for us as a technology supplier, we see that there's massive implications of this, and we'll talk about that in just a few minutes. But also as a consumer, we see that the cars actually can be really bringing tangible benefits. So, for example, if you compare, let's say, the Audi R8, which is one of the fastest cars in the world that you can buy as a reasonably affordable price level, though still expensive, and you compare that to, say, a Tesla Model S, which is maybe somewhere around the same price point, in a performance sort of car category, you see that Tesla does extremely well. So the point there being that electrification brings with it not only massive change as far as the cars are actually designed, but also tangible benefits to us as consumers. So if we look at electrification, again, of cars and look at it now from an OEM perspective, what we see is that over the next 5 to 7 years, we see and we expect a massive shift away from internal combustion engines and towards electrification or electric vehicles by something around a factor of 10 or so. This year, or maybe last year, there was something around 2 million units shipped in the world of electric vehicles. And what we see is by 2025, this will go up by a factor of 10 or so. And if you look at it regionally from an OEM perspective, what you see is that China invested early, partly because of regulations, partly because of the desire for leadership. And those OEMs are sort of aggregated into the top line of the chart, showing that they make up about half of all of the worldwide electric vehicle shipments last year. And going forward, going up by something like a factor of 4 or so. But if you look at the rest of the world, Volkswagen and others across the world, they also are continuing their massive shift over towards electric vehicles, thanks to the leverage that they bring in terms of their ability for those OEMs to focus on mass market cars. They can rapidly grow, and actually, if you look at the growth rates, we expect that the growth rates tilt away from China and over into Europe and Japan for the next 5 to 7 years. So we're talking about electrification, we're talking about electric vehicles. Actually, electrification is much more than just the car. It actually extends beyond the car into a whole wide ecosystem that covers everything from the battery industry, which is really the heart of every electric vehicle, through car manufacturing, out to, of course, us as consumers, into the charging infrastructure, into the smart grid itself, and then back into the very source of power generation. And what we see is when we look at it from that perspective, electrification is really important, especially here in Europe. 14 million jobs just in the automotive car manufacturing itself. And if you look at the battery industry, actually most of the world's batteries for electric vehicles are manufactured outside of Europe. We expect that will change. And there's some recent announcements supporting that there will be a local presence in Europe for battery manufacturers. Also, the last thing that I think I'd mention is the importance of regulations, especially here in Europe, really driving the industry, driving growth despite the more wider macroeconomic factors. So for example, Europe has set a very aggressive energy target, 32% of its energy coming from renewables by 2030. So that helps drive that part of the ecosystem. So our technology, when you look across the ecosystem, actually extends across a whole wide variety, across everything, really with the exception perhaps of the smart grid itself. Energy storage systems, battery formation and test, precision battery management, which we'll talk a little bit about today, powertrain inverters, I'll also touch a bit on those, and charging systems. All of these are applications of analog devices technology, and we're really pleased to be able to take such a leadership role across such a large part of the whole electrification ecosystem. So we also have a way of looking at the battery itself, and I think this may be kind of a different way, maybe a different perspective to bring as far as you think about electric batteries. First of all, electric batteries are extremely important. Compared to the total bill of materials of the car, you're looking at about a third of the cost of a pure electric vehicle is coming from the battery itself. So we look at the battery not only as a, let's say, prime determining factor on the range of the vehicle, which for us as consumers is a key consideration, but also we can look at it as an asset. It's a $10,000 asset, essentially, in the electric vehicle. So what do you do with that asset? And the way that we think about that is we map the battery journey, that we call it, all the way from battery formation, all the way through something we call second life. And all along the way, there's different technology challenges that we as analog devices can apply our technology. So for example, during battery formation, there's a very precise, controlled set of steps that are required to ensure that you create high-capacity, safe batteries. This requires very accurate control of the chemical parameters. We provide technology that goes into the instrumentation that actually, during battery formation, creates very high-capacity cells. Then you have the battery going through a warehouse, through transportation, eventually through pack manufacturing, pack assembly, manufacturing the vehicle, on the road, used for some amount of time, and then you get to the end of life of the car or the battery. At some point then, what happens? And that becomes a very interesting question around how our technology can actually start to apply that. So what do we do there? There's mechanisms that can be applied, algorithms and so on, that determine not only the state of charge, but also the state of health of the battery. So as you're following the battery through that journey, you can imagine that as you are getting near the end, and based on how you're using the battery, under what conditions, and so forth, that gives you an indication of how much health might be left in that battery when the car might be reaching its end of life. So the way that we call this is really a battery journey from formation all the way through second life, and those are some areas here that you see how we intersect that. We also have power isolation technology. So when you go on the fab tour here at Analog Devices, you'll see that actually we have developed world-leading isolation technology as far as power goes. So anytime you've got communications and power together, you'll have our isolation technology found. So there's a number of major product families. We've been shipping the product for a very long time. And really innovating there, investing in the facility here in Limerick, shipping over 3 billion units and continuing to ship more across a whole wide range of applications. And so this is, I think, a very interesting part of the electrification story, that whenever you have something needing to communicate and something needing to interact with high power, that's where isolation technology has a role to play, and that's developed here. Let me focus a little more on battery management. And what I want to focus on there first is, well, what's really the impact of battery management? We talked about the battery journey. We talked about when the car is actually in use. what the battery management system does is actually for us as users, it's enabling the safe and accurate power delivery into the car during charging, or out of the battery when you step on the throttle. So we did a calculation and we said, well, we've been shipping for over 10 years. Why don't we take a look at our 12-volt battery management systems as well as our electric vehicle battery management systems, and let's calculate how much carbon dioxide we save based on the cars that are shipping with our technology inside. And what we found was that this year we're on track to save 75 million tons of carbon dioxide entering the atmosphere just this year. That's equivalent to 80 million acres of mature forest. So that's something that we're really proud of in terms of an environmental impact and footprint there. And as you go forward, you can see how, as the shipments grow, our impact continues to grow. So let me dive a little more into the battery packs. So what is the battery pack? Well, the battery pack is basically the collection of battery cells that's distributed around the car, typically sort of just on top of the chassis. And they need to be shaped in certain form factors that fit the design of the vehicle. And for us as consumers, we don't maybe necessarily care so much about what the battery pack itself looks like, but we definitely care about how much range we can get out of the vehicle or how fast or slow it might take to charge the vehicle. So what we've done is our technology actually maximizes the available usable energy in the battery pack. And it does that by creating very precise voltage measurements that are guaranteed across the whole life of the vehicle and the life of the battery. And what that does is by those precise voltage measurements, you can accurately discharge the battery and you can accurately charge the battery. And so that maximizes the usable capacity of the battery. So this simple calculation that I showed for you there, our technology can save anywhere from 10 to 20%, basically increasing the usable capacity, increasing the range. That's really significant, and it's something that the industry recognizes for us. There's another interesting aspect of the battery pack itself, which is there are new safety regulations coming that will require a shutdown at least 5 minutes before thermal runaway. Why is that important? Obviously, well, thermal runaway can lead to negative conditions, fires, etc. What we do is these safety regulations say that 5 minutes before that occurs, you've got to be able to predict the conditions that could lead to that, and then somehow set a flag so that the car itself will know that the battery pack is potentially reaching an unstable or dangerous condition. So those types of safety regulations are extremely important, and our technology also supports those types of regulations. So if I look into the future a little bit, sometimes say, okay, great, so what do you see coming up next? Well, let's first look into the past a little bit. Back 10 years ago, the way that battery packs were managed was fairly crude. You had single board designs. You used sort of large, clunky circuits, and they tended to be fairly expensive compared to what you see today, which are more modular designs. These modular designs allow the packs to be built in chunks. And so when the packs are assembled, those chunks can be collected together. If you're building a high-end vehicle with a large battery capacity, you put a lot of the chunks together. If you're building a low-end vehicle, a more mass-market vehicle, you put only a few chunks together. So this ability to modularize actually has a large impact in terms of cost savings, in terms of efficiency for battery pack manufacturers and for car OEMs. That's what we see today. Now when we look into the future, what we see is these chunks of cells, or these chunks that are created to form these battery packs, actually can be connected together wirelessly. That's a really exciting type of technology where Analog Devices has developed a unique ultra-low power network that eliminates the wire harness. So these battery cells still are connected together to deliver the power, but they also are connected together wirelessly to communicate with each other. That wireless communication eliminates wires. Eliminating the wires saves weight and improves the efficiency of the system. Plus, it gives you a lot of flexibility in terms of how you assemble these battery cell chunks altogether. Plus, it gives you the ability to do real-time monitoring of each of these chunks of battery cells wirelessly. So that's really where we see the future. Now, if I cover the infotainment piece of it, or at least what I call infotainment, let's think of it really more as how does the driver or the passenger interact with the car. And what I would say here is that, if you look back 100 years ago, we started out as drivers where, drivers had to see the road. You got behind the wheel, you put your hands on the wheel, you stepped on the gas, and the car kind of chugged along, and you drove the car. What started to happen in 2012 or so was the car actually started to see the road for you. There's cameras there, there's rear view cameras, there's front cameras, and along that journey, cars started to become more intelligent because now they're watching the road. And of course, if you think about the level 4, level 5 type robotaxis that Chris was talking about, the cars are becoming extremely aware of what's going on with all their surroundings. But there's another interesting aspect of all of that, and that is that the car not only has to look outside itself to see the surroundings, but it also needs to look inside itself and see what the passenger or the driver may be doing. So for example, in the case of a handover, that's one of the most tricky parts of autonomous driving. So the driver's behind the wheel, let's say the car is put into an autonomous mode, and away you go on the highway, let's say doing stop and go driving. Well, at some point, let's say you want to retake control back from the vehicle. How exactly does the car allow that handover to happen? If it's a type of normal driving situation, let's say it's more like a cruise control, well then you could maybe tap the brake and the car would sort of go out of autonomous mode and go back into a regular driving mode, turning all the autonomy features off and allowing you to drive the car, no problem. But what if you're in an emergency situation, and maybe if the driver is upset or panicked and maybe grabs the wheel during some kind of emergency maneuver, what should the car really do to keep the driver safe? Should it allow the driver to regain control, or should it maybe keep control for itself? Because if it has confidence in its surroundings, only it knows where to go, maybe even better than the driver. So it's an interesting type of challenge, all of which requires the car to see the driver and to understand the state of emotion of the driver. And actually, our view is that in order for autonomy to really fully take off, we see this type of driver monitoring as really an essential component that's leading towards autonomy. So we see not only the car seeing outside itself, but seeing back in itself as steps along the journey to self-driving. So there's another aspect of infotainment. So we as passengers or as drivers like to bring our sound with us or our music with us on our phones. We bring those into the car, and we would like to have what we call an immersive type of sound experience. So there's a variety of ways that the industry is sort of addressing that. The first is relatively simple, where you cover the inside of the car with speakers. And I think most of us as drivers or passengers have sort of seen this trend over the last 10 or 15 years, where sort of whether you want it or demand it or not, the sound systems have become more and more sophisticated in even mass market vehicles. So that creates a challenge for us as a technology supplier. How do you handle that? How do you do that? Well, we saw this trend coming actually quite some years ago. So what we developed was a special type of technology that allows the speakers to be connected together using unshielded twisted pair. That's the cheapest, most cost-effective type of way that you can connect high-fidelity audio speakers. But it's really challenging because you need these special chips to actually translate these high-quality audio signals into simple signals that can travel across the unshielded twisted pair. So that's one way that we've enabled that type of immersive sound experience. The other type of trend that we've seen is programmable sound and sound synthesis, sound programming. And I'll talk a little bit about the technology we have there. But the point is that we as drivers or passengers like the ability to be able to customize the sound. Now there's also something else, which is called audio zoning. So I'm not sure how many of you know or have had the experience, but audio zoning is a very interesting type of technology. Basically, the idea is you're sitting in the car, let's say I'm the driver, and I want to listen to my type of music, and let's say my colleague, passenger sitting in the next seat, wants to listen to something else. Audio zoning allows the passenger to hear their own cocoon of sound and not interfere or not be able to even hear the cocoon of sound that could come over into the driver. So these individual zones can actually be programmed and can actually, that technology is in development and can actually work pretty well. You can also use that technology in reverse. So as you want to interact with your car, people are familiar with the voice commands. The voice commands work best when the system is listening just to the driver. So if you use the audio zoning in reverse, you can imagine a type of microphone beamforming where when the driver is speaking, the car is just listening to the driver. And that's a type of technology that we also see really entering in to mainstream vehicles. And then there's some other techniques here that I've listed: echo cancellation, noise cancellation, sound generation. There's a concern that electric vehicles, while they're better vehicles, they're also very quiet vehicles. And while that might be, nice from a home theater experience in the car, it's not so nice necessarily to pedestrians who might get surprised by an upcoming electric vehicle. So there's actually a technology which allows generation of sounds outside the vehicle. So maybe if you're driving the vehicle in Rome, maybe you want it to sound like a Ferrari. Maybe if you're driving the vehicle somewhere else, you can have it sound like something else there. Performance audio, I said I wanted to mention some of the technology we have there. Actually, we've been shipping performance audio complete systems for quite a number of years as analog devices. And what we see, actually the importance of audio is very interesting. Audio is one of those types of, let's call it a soft science, where you have engineering and technology, but on top of it, you have sort of an art of creating pure sound. So typically at OEMs, there'll be somebody with what they call the golden ear that will actually listen to how the sound is coming out, and they may say, yes, no, not so sure, and depending on what they say, the sound needs to be tweaked. So it's a kind of a subjective type of experience. Well, that's only facilitated if you have a complete platform of tools that allows all sorts of customization and tweaking many different parameters, all to fit within the interior of the car, covered with all of these speakers. You can imagine things need to be customized just so that the person with the golden ear can give the thumbs up, and then when we as the consumer get into the car, we really like the sound. So our technology ships not only into vehicles or electric vehicles, but it also ships into pro audio mixing consoles. It ships into sound bars. All of this type of technology, we're very excited to bring directly into the vehicle. Also, I want to talk about connectivity. I touched on it a little bit as far as how the speakers are connected together. The technology that we invented is called the Automotive Audio Bus, or A to B. We were the first in the industry to create this, and actually there wasn't a standard. So what we did is we said, well, we know that this is a value that we have to have, so let's invent something that works better than anything else out there. And that was the genesis of the A to B, the Automotive Audio Bus, which is now shipping in large quantity out across the industry. We've taken that and we said, well, we see another kind of trend. So like Chris Jacobs was talking about with autonomy, we see the growth of these domains that are coming up all around the car. So you have all of these many different types of ECUs all connected around the car that need to have signals flowing between them at different data rates. So not only from the head unit or from a remote amplifier module to a speaker, but maybe between a sensor and an ECU that's going to do the number crunching. Or maybe between a camera sensor and a processor. So what we created is something called the car camera bus. It's similar to the A to B in the sense that it uses very low-cost physical transport mechanisms, the unshielded twisted pair, but it provides very high data rates. So for something like a rear view camera, this is absolutely the way to go. It gives fantastic image quality, it gives high data rates, very nice image fidelity over what's going to be the most efficient in terms of weight, size, and power in the industry for video signals. And again, because it's an electric car, what you have, or if it's an electric car, then size, weight, and power, even more important as we get back and think about the battery and how it needs to be able to generate most miles per charge. So even the power that you're generating or that you're consuming while the vehicle's in motion is potentially taking away from your range. Lastly, the bit of connectivity that I want to talk about is the Ethernet to the edge. So most everyone, I think, is quite familiar with the fact that Ethernet is entering into the car. No question about that. But there's a type of Ethernet that we're developing that actually allows you to push out to the edge of the communication network in the car, push out to the edge in a very cost-effective way, Ethernet. So it means that if you want to put, or when the car has these sensors located all around the car, each one of these can have an Ethernet address, but don't need to have a complicated microcontroller associated with it. Just a simple, very low-cost chip connected to the sensor can give you Ethernet to the edge. So it's a very exciting technology. The last technology I'll talk about is connectivity. So as you look across all of this and you think about all these different versions of wired connectivity as the car is becoming more and more complex, you could ask yourself the question, well, okay, what's the ultimate way to save weight in terms of wiring? That's wireless. So what we see is certain pieces of the car, not only the battery, which we talked about before, but also other types of connectivity in the car, we see that also becoming wireless. So the point here is that we see wireless as taking a larger and larger role in the car. Now that comes with also some challenges around security, safety, and so forth, but those are just the types of challenges that we like to tackle here at Analog Devices. Key takeaways. First of all, you've got a number of different market growth drivers. I talked about 10x growth in electric vehicles. Even despite what you see around the world, electric vehicles are going to grow. And also we see this battery second life concept. We see that as becoming even more important when you start to view the battery as an asset in the electric vehicle, not just as a determiner of how we as a consumer, how much range per charge we get, but also in terms of an asset that we can reclaim. We see the growth in immersive car audio, no question, and we also see an increasing push to eliminate wires, whether it's wireless or whether it's through some other type of technology. In terms of impact, we're really proud to be able to save carbon dioxide emissions, as an example. And we're also really proud to be able to enable battery packs to have a large number of miles per charge. That's a key care about to enable electric vehicles to become mainstream. We also see premium audio becoming mainstream, and that's also an important impact to enable us to have fun while we're in the car, whether we're passengers or drivers or both. And at the end of the day, as we look ahead, we see just a continuing challenge around innovation, and wireless certainly becoming a big part of that future. So thanks very much. And what's our last maybe message I'll say is good technology, challenging technology, that's what we do. If it's good technology, it's good for the planet. If it's good for the planet, it's good for all of us. So thank you very much.